In this lesson, we're going to talk for the first time about how to actually construct a sign chart. To do this, we will look at a couple of examples after having first talked about some key terminology. So I'm going to leave a little bit of blank space here, but for our first example, we're going to construct the sign chart for the expression x minus 2 times x plus 3. I want to make something very clear before I proceed that we are just constructing a sign chart here. So you might be thinking, wait a minute, in the last lesson she was talking about inequalities? Yes. In the last lesson we were talking about how any inequality can be turned into a question about sign. But in order to come back to talking about inequalities, we need to figure out how exactly we're going to go about constructing sign charts. For our second example, we'll look at something a little bit more interesting. We'll look at an expression that has 3 factors, but you're going to notice that in all of the examples that we do here, since this is our first lesson, everything is going to come pre-factored. So kind of a logical next step in our next lesson will be what happens if you're looking at a situation where things aren't pre-factored. So we'll definitely build to that. Remember, I mentioned this in our previous video, that a sign chart is an actual chart that talks about where is an expression positive and where is it negative. So what I want to introduce to you is this notion that 0 is a gatekeeper. So I'm going to say here idea. The number 0 as a gatekeeper. What do I mean by that? What I mean is that if you're going to change sign from positive to negative, you have to pass through 0 along the way. It's a little bit of an oversimplified statement. That's not 100% true, but for our purposes right now, it is. 0 becomes a really important value. So at this moment, I want to introduce a definition. A number is called a critical value for an expression if that number makes the value of the expression 0. And that's where we are going to start every single time that we construct sign charts. We're going to start, and I'm actually going to keep it in red here. We're going to start by identifying the critical numbers. Now, to keep the color coding, I'm just going to remind you that critical numbers are asking when is the expression equal to 0. Okay, so let's see. What would make x minus 2 times x plus 3 0? Well, we know that the 0 product property tells us that if 2 things multiply to 0, one of them has to be 0. X minus 2 is 0 when x is 2. X plus 3 is 0 when x is negative 3. So again, I'm setting this expression to 0 using the 0 product property. The next thing I'm going to do, and in future examples we will speed up this process, but I'm going to think about this as a product. So if I'm multiplying 2 things, when is the product going to be positive? The product is positive when both of the factors are positive or both of the factors are negative. When is the product going to be negative? When one of the factors is positive and the other factor is negative. So what I'm getting at here is I want to think about the individual factors before I think about the entire product. So what you'll see me do, and in fact, I have students who do this the entire time. What you'll see me do is you'll see me make these build-up sign charts where we look at the sign charts for individual factors and then we combine them to get the sign chart of the whole expression. Again, this takes longer, but I will have students every single semester for whom this is the most clear way to build a sign chart and they stick with it. Okay, so x plus 3. So x plus 3 is 0 when x is negative 3. So I'm going to mark that here. This is just a number line. Okay, so you can, the scale that you use is totally up to you. How much you label is totally up to you. I like to label only the critical numbers because I think it's more clear that way. And x minus 2, the critical number there is 2. And then in purple here at the bottom, I'm going to put down my final sign chart. What I'm actually going to do is I'm going to dot down here and here. So now it actually sort of looks like a chart. Okay, so here we go. What values of x will make x plus 3 positive? So think about values that are greater than negative 3. So for example, here you might have 0, right? Or negative 1 or 1. What happens when you plug these values in for x? Well, negative 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. All of those are positive numbers. So I'm feeling pretty confident that for any value that's between negative 3 and 2, x plus 3 is positive. Very similarly, you can see that if you take a number that's greater than 2, x plus 3 will be positive there also. Like if you plug 3 in for x, or 4, or 5, x plus 3 will be positive. So it looks like x plus 3 is positive everywhere to the right of negative 3. Now, if we look here to the left of negative 3, like maybe negative 4 or negative 5, if you plug those in for x, x plus 3 is in fact negative. So it turns out that to the left of negative 3, x plus 3 is negative. Okay, now let's move on to x minus 2. You're going to notice something very, very similar. If you're taking values to the right of 2, like 3 or 4 or 5, and you're plugging them in for x, what you get is that x minus 2 is positive. So x minus 2 is positive everywhere to the right of 2. However, if you start looking at numbers that are to the left of 2, so like for example, you might look at 1 or 0 or negative 1, right? If you plug any of those in for x, x minus 2 is negative. So we're negative between negative 2 and 3. And by that same token, if you look at values that are to the left of negative 3 and you plug them in for x, like negative 4 or negative 5, or any other number to the left of negative 3, you plug them in for x, x minus 2 will be negative there as well. Alright, so now we are ready to construct the final sign chart. So remember how we talked about the fact that the purple sign chart is kind of the product sign chart. We are multiplying these two factors together to get our final product. So we talked about how if you take a positive number times another positive number, you end up with a positive value. Okay? However, if you take a positive number and multiply it by a negative number, you get a negative back. And last but not least, If you take a negative number and you multiply it by another negative, you get a positive number in the end. So there is the final sign chart of the expression x minus 2 times x plus 3. I'm not going to do it in this example, but I want you to notice that we are now in a position where we could actually solve an inequality. Like, where is x minus 2 times x plus 3 greater than or equal to 0, for instance? Now let's move here. So we're going to construct a sign chart for the expression x times 2x plus 1 times x minus 5. So notice there are 3 factors here. First order of business, what are the critical numbers? So remember, when we're looking for critical numbers, we are setting the expression to 0 and seeing what values of x make it 0. So this is the good old-fashioned zero product property. One by one, we're going to set each factor to 0 and see what we get for x. So as I always say, if you need to pause the video right now and stop and think for yourself, okay, what would x need to be in order for x to be 0? Okay, what would x need to be in order for 2x plus 1 to be 0? So if you want to write that out, remember that I am expecting that you're engaging with these videos as you watch them. In order for x to be 0, x has to be 0. So in this instance, notice 0 is actually one of our critical numbers. This will happen sometimes. Not every time, but it does happen. In order for x to be 0, in order for 2x plus 1 to be 0, x has to be negative 1/2. And in order for x minus 5 to be 0, x has to be 5. Okay? So again, I didn't do it here, so I encourage you to do it on your own if you need to. What I'm doing here is I'm setting each factor to 0 and solving for x. All right. So now I'm going to do exactly the same thing that I did in the previous example, except now I have 3 factors, not 2. So there they all are. As before, I'm using the same color coding system, the individual factors in black, and then the final product in purple. Okay. One of the things that I wanted to show you in this particular example is that when it comes to the number lines, position is much more important than scale. So the critical number that came from the factor x is 0. So I'm going to put 0 here. I'm mindful of the fact that I also have a critical number of 5 later, so I want to make sure that there's space to mark the 5. So I don't want to put the 0 too far left. The critical number for 2x plus 1 is negative 1/2. So again, it doesn't really matter where it is distance-wise, as long as it's to the left of the 0. So as you're kind of mapping ahead and you're thinking, okay, negative 1/2 and 0, they should have that proper position where negative 1/2 is to the left of 0. Okay, and then by that same token, x minus 5, the critical number from that is 5. All right, and then the final grid here, right? So there's negative 1/2. There is 0. And there is 5. Exactly where these numbers are is not important. You could have them closer together or further apart as long as they're in the right position. So negative 1/2 is to the left of 0. 0 is to the left of 5. One of the most frustrating problems that I run into with students, not frustrating for me, frustrating for them, is that they seem to be doing everything right, but the sign chart is coming out weird. The reason that happens is because we accidentally don't do the right position. So I'll see someone really, really frustrated. Why isn't this working? Well, they have negative 3 to the right of negative 1. And it's throwing everything off. So really focus on that position. All right, off to the races. So, X. I'm going to do this a little faster this time, and if you need to, slow it down for yourself, so pause and think for yourselves, please do. X is positive for all values that are to the right of 0 on the number line. And X is negative for all values of 0, all values of X that are to the left of 0 on the number line. The same is going to be true for 2x plus 1. 2x plus 1 is positive for all values of x that are to the right of negative 1/2. And 2x plus 1 is negative for all values of x that are to the left. I don't want you to get too comfortable with this. It's very easy to see this pattern and to think, oh, it's always going to be this way, that the value's positive to the right and negative to the left. That is a good pattern to notice because it is true a lot of the time, but it's not true all of the time, and I'll make sure to show you at least a couple examples where it doesn't hold. So it's important that you're engaging and you're not just automatically assuming positive on the right, negative on the left, because it won't always work that way. It will work that way a lot, but not every time. It does work that way for x minus 5, however. X minus 5 is positive when x is to the right of 5 and negative everywhere else. Now, the thing that's kind of interesting about this example is that we have 3 factors. So we have to be thinking what happens when you multiply 3 numbers. So looking at our final product here, let's just go left to right. For this region here, we're going to multiply a negative by a negative by a negative. So negative times negative is positive, but then the third negative brings it back to negative. Okay. Next section. We have negative times positive times negative. Negative times positive is negative, times negative brings it back to positive. Next section, we have a positive times a negative. So positive times positive is still positive, but then the negative makes it negative again. Last region, we have positive, positive, positive. Product of 3 positive numbers is positive. So there is our final sign chart. So one thing that I want to do before I leave you here, and this may be something that you can refer back to if you choose to rewatch this video or rewatch part of it, I just want to take this opportunity here to kind of remind us of something that we used a lot in this video, but we're going to use it a lot moving forward also. If you take 2 positive numbers and you multiply them together, you end up with a positive number. If you take 2 negative numbers and you multiply them together, you get a positive number. And if you take 2 numbers of opposite signs and you multiply them together, you get a negative number back. So this is something we used extensively in these 2 examples, but I figure it doesn't hurt to actually have it written out. Okay, that's the end of our first lesson on constructing a sign chart. Stay tuned for the next lesson. Bye.